All right, so we're diving into this stack of notes,
Okay.
chapters that we got from design gurus grokking the system design interview.
Right.
Really going to go deep on how to prepare for these system design interviews.
Yeah,
This book seems like the resource for that.
for sure.
But let's be honest, these interviews are
Yeah.
kind of notorious.
Yeah.
They're known to be pretty tricky,
Oh, absolutely.
even for seasoned engineers.
Yeah, they can be real head scratchers, even
Eh,
for people with a lot of experience.
Yeah, and the book really breaks down why they're so tricky, and
Yeah.
it really resonated with me.
Yeah.
The first thing is just that open-endedness,
Yeah.
right? It's not like a coding challenge
Yeah.
where,
Yeah.
there's a clear right answer.
Yeah.
It's all about trade-offs
Yeah.
and making, informed decisions based on the specific problem.
Exactly.
Yeah.
Yeah. It's a lot more about thinking critically and weighing different options.
Totally.
Yeah. And that actually leads right into that second challenge is that it takes experience. The interview often wants you to have designed systems that you haven't built in the real world.
Right.
It's like asking someone to design a skyscraper when they've only built sandcastles.
Yeah,
You know?
that's a great analogy.
And so, like, how are you supposed to do that?
Right.
And that's where, I think this book shines.
Yeah.
But it is a really common pitfall.
Yeah, and the third point the book makes, which I
Yeah.
thought was really interesting and really hit home for me,
Mhm.
was that most people just don't prep right for these interviews.
Yeah.
You can't cram for system design
Yeah.
like you would for like a history test,
Right.
you know? It's about building a mental framework.
It's a way of thinking.
It's a way of thinking about these problems
Yeah.
systematically.
And that's exactly what this book tries to give you,
Yeah.
is that framework so that you're not just memorizing solutions.
Yeah.
You're learning a process.
All right, so let's walk through that framework.
Okay.
The first step is requirements clarification.
Yes.
It seems so obvious.
Yeah.
But the book really stresses how absolutely vital this is
Uh-huh.
before you even think about design.
It's about asking the right questions.
Yeah.
Imagine you're asked to design like a Twitter-like service
Okay.
before you go sketching anything.
Right.
You need to know, like, will tweets have photos and videos?
Right. Are we building both the front end and the back end?
Exactly. Yeah, are we focusing on certain features like search or trending topics?
Right.
These details drastically change the scope of the problem.
It's like, the difference between planning a weekend camping trip
Yes.
and like an expedition to climb Everest.
Exactly.
The prep is completely different.
100%.
Okay, so once you've got a solid grasp of the requirements,
Yeah.
you move on to step 2, system interface definition.
Yes, this is where you actually define the APIs that your system is going to use.
Okay, so for our Twitter example, we'd be thinking about APIs like post tweet,
Yep.
generate timeline, follow user, and so on.
Exactly. And each API needs clear inputs and outputs. Like, what is it expecting and what is it giving back?
Right.
And defining those forces you to think about what actions a user can take on the system
Yeah.
and what data is flowing through it.
It's like laying out the blueprint before you start building the house.
Yeah, for sure.
Okay, so now before we kind of get lost in the weeds of detailed design,
Yeah.
the book emphasizes step 3, back of the envelope estimation.
This is a fun one.
I love this part.
Yeah.
It's all about making, sort of educated guesses about the scale of the system.
Yep.
How many users will we have?
Uh-huh.
How much data will we store?
Right.
How much traffic can we handle?
Yeah. How many requests per second are we going to get?
Right.
How are we going to scale for that?
Right. And the book uses a URL shortening service as a case study
Yeah.
for this step.
It's a good one?
Yeah, walks through,
Yeah.
estimating things like how many new URLs will be shortened every second?
Uh-huh.
How much storage do we need to keep all those shortened URLs and their mappings for years?
Right.
And even how much memory do we want for caching frequently accessed URLs?
Exactly. It really highlights the importance of thinking about scale from the beginning.
Yeah, yeah. I remember in a past interview, I jumped straight into the design and I completely forgot about load balancing.
It's a very common pitfall.
Yeah.
And this book is good at helping you avoid that.
Okay, so moving on to step 4, defining the data model.
Okay.
This is where we sketch out all those entities and relationships within our system.
Right.
So for Twitter, our entities might be user, tweet, follower, and so on.
Exactly.
And we define how they relate to each other.
Mm.
A user can post many tweets. A tweet can be retweeted by many users, and so forth.
Precisely. And this step is super crucial
Yeah.
because it forces you to think about how data will flow between different parts of your system
Right.
before you design those parts.
It's like figuring out the plumbing before you start building the walls.
Yes.
All right,
Exactly.
now we get to the exciting part. Step 5, high-level design.
Okay, this is where we start sketching that system architecture,
Yeah.
breaking it down to core components.
So for URL shortening, we might have a key generation service to create those shortened URLs,
Mm-hmm.
a database to store those mappings, and then some logic to handle those redirects
Yeah.
when a user clicks a short link.
And, keep it visual.
Yeah,
Boxes and arrows at this stage.
right. It's all about boxes and arrows.
Don't be afraid to iterate.
Yeah.
Start simple and refine as you uncover more details.
Okay, and finally, step 6, detailed component design.
Now we're zooming in.
Yeah.
We're getting into the nitty-gritty.
Yeah, now we zoom in on each of those components and we flesh out how they actually work.
Exactly.
So for Twitter, this could involve diving into, how tweets are stored and retrieved,
Yep.
how user timelines are generated, how to handle notifications, and so on.
Exactly.
This is where your knowledge of specific technologies and trade-offs really comes into play.
What database should you use?
Right.
Should you use a message queue?
Right.
What are the pros and cons?
It's where the rubber meets the road.
For sure. And the cool thing about this book is it doesn't stop at the framework.
Right.
It goes on to apply these steps
Yeah.
to a whole bunch of real-world systems.
And that is what we are going to be diving into next.
Yes, we've got a lot of ground to cover.
We do.
From URL shortening and paste-to-bin
Yeah.
to, complex systems like Dropbox and YouTube.
Yeah.
Each example reveals unique challenges and design considerations.
And remember, this deep dive is all about understanding the why behind the design choices,
Yes,
not just memorizing solutions.
100%.
We're going to be highlighting those aha moments and those insights that are going to help you ace those system design interviews.
Absolutely. And I think a good place to start is
Right.
with that first real-world system URL shortening.
Okay.
So buckle up.
All right, I'm ready.
It's going to be a fascinating ride. Okay, so let's jump into the world of URL shortening using tinyURL as our guide.
Okay.
It's a fantastic example of how a seemingly simple system gets super complex at scale.
Oh, I'm already intrigued.
Yeah.
I use URL shorteners all the time, but
Right.
I never really thought about what goes on behind the scenes.
Right. At its core, it's about taking a long URL, creating a short code,
Yeah.
storing that mapping, and then redirecting users when they click the short link.
Right.
Simple, right?
Yeah.
But when you're dealing with a service like tinyURL that handles millions of URLs every day, things get a lot more interesting.
Yeah, the scale alone is mind-boggling.
Right.
Like, those short links need to work reliably,
Yeah.
potentially for years,
Yep.
and they need to be accessed quickly.
Yes.
That's a lot to consider.
Exactly. So the book walks us through, some key design decisions.
Okay.
First up, generating those short codes.
Yeah.
We could use a simple counter,
Yeah.
but that's predictable and prone to gaming.
Right. Plus, you'd have to deal with collisions.
Yes.
What if two users try to shorten the same URL simultaneously?
Exactly.
Chaos.
Right. The book presents a clever solution, generating keys offline. You pre-generate a pool of random unique codes
Ah.
and store them in a database.
Okay.
When a user needs a short URL,
Right.
you grab the next available code from this pool.
That's a neat trick.
Yeah,
No more collisions, and it speeds up the shortening process.
exactly.
Because you're not generating codes on the fly.
Now let's talk storage.
Okay.
We need a database that can handle billions of records each, a short code mapped to a long URL.
Right.
And it needs to be fast
Yeah.
because users expect those redirects to be instant.
Right. So a key value store like Redis would be a good fit here, right?
Exactly.
Known for its speed and ability to handle massive amounts of data.
100%. And to make things even faster, we can add caching.
Okay.
Frequently accessed mappings
Yeah.
can be stored in memory for ultra-fast lookups.
It's like having a shortcut to the most popular destinations.
Exactly.
Right.
Now, the book also delves into custom aliases.
Okay.
Remember, some URL shorteners let users choose their shortcode.
Oh, yeah, that's a cool feature.
Yeah.
But I imagine it creates some challenges.
It does.
Like, what if two users want the same custom alias?
Yeah, that's a good point.
Yeah.
You could use a first-come, first-served approach,
Right.
but then you have to worry about people hoarding popular aliases.
Right.
It's a constant balancing act between user flexibility
Yeah.
and preventing abuse.
Okay.
And speaking of abuse,
Mhm.
the book doesn't shy away from the security aspects of system design.
Right. It's not all fun and games.
Exactly. We
Yeah.
need to think about rate limiting
Mm.
to prevent a single user from flooding the system with requests.
Right.
We also need to protect against malicious hijacking of short links.
Yeah, that makes sense.
So to recap, we've got offline key generation,
Cool.
efficient storage, with caching, custom alias handling, rate limiting, and security measures.
That's a pretty robust system.
It's a solid foundation for
Yeah.
a URL shortening service.
Okay.
Now let's move on to Pastabin,
Okay.
which at first glance seems quite similar,
Right.
but it has its own unique twists.
I'm ready for the next challenge.
Okay.
From what I remember, Pastabin is all about sharing larger chunks of text,
Exactly.
like code snippets or log files.
Exactly. So right off the bat, storage becomes a bigger concern.
Yeah.
Instead of short links, we're storing potentially large amounts of text data.
Right. And we also have to think about those user-specified expiration times.
Yes.
Some pastes might be meant to be temporary, while others need to stick around longer.
That raises an interesting design question.
Yeah.
Should we impose size limits on those pastes?
Okay.
We want flexibility for users,
Right.
but we don't want someone uploading a novel and breaking the system.
Right. It's all about finding that sweet spot
Yeah.
between user freedom and responsible resource management.
The book also points out the issue of duplicate entries,
Okay.
especially when parts of a URL might be encoded differently.
Right.
It suggests appending a unique identifier to each paste to avoid those accidental duplicates.
Yeah, that's a subtle detail,
Yeah.
but it's really important for maintaining data integrity.
Exactly.
Okay, so how do we handle all this data from a storage perspective?
Yeah.
Would we still use a key value store like Redis?
So for Pastabin, the book recommends a slightly different approach.
Okay.
We'd use a relational database to store metadata,
Okay.
like user info and paste details,
Right.
and then leverage object storage like Amazon S3
Okay.
to store the actual paste content.
That makes sense.
Yeah.
You get the structured data management of a relational database for metadata,
Uh-huh.
but you also have the scalability and cost-effectiveness of object storage for those potentially large chunks of text.
Exactly. Plus, we can scale those components independently as needed.
Right.
And similar to URL shortening,
Yeah.
we can use a standalone key generation service to ensure uniqueness and avoid collisions.
Okay, so Pastabin is down.
Yes.
Are you ready to crank up the complexity?
I think so.
Let's talk photo sharing,
Okay.
specifically something like Instagram.
Now we're entering the realm of massive data.
Right.
Images and videos bring a whole new set of challenges.
Starting with storage,
Yeah.
we need a system that can handle terabytes,
Right.
maybe even petabytes of data.
And it's not just about storing it.
Right.
It's about retrieving it quickly.
Yeah,
Users expect to see those photos and videos instantly,
100%.
whether they're scrolling through their feed
Yeah.
or browsing someone's profile.
Speed is key.
Right.
So data partitioning becomes crucial.
Okay.
We need to distribute those photos and videos across multiple servers to handle the load and ensure those speedy access times.
Okay, so the book recommends consistent hashing for this.
Yes.
Could you break down what that is
Sure,
and
right.
why it's a good fit here?
So consistent hashing is a technique that helps us distribute data evenly across multiple servers.
Okay.
Imagine you have a ring,
Okay.
and each server is a point on that ring.
Mm-hmm.
You then hash the data and map it to a point on the ring.
Okay.
The data is stored on the server closest to that point.
Right.
And what makes this consistent?
Yeah. Is that if you add or remove a server,
Right.
only a small portion of the data needs to be remapped,
Okay.
minimizing disruption.
Ah, that's a much clearer explanation.
Right.
I can see why that's important for a dynamic system like Instagram,
Yeah.
where you might be adding or removing servers all the time.
Exactly. Now, another challenge with photo sharing
Yeah.
is designing that feed that shows the most relevant content from all the people a user follows.
Right.
It can't just be chronological.
Right.
It needs to be personalized and engaging.
Yeah, like a curated gallery highlighting the best and most interesting content.
Exactly. The book delves into using ranking algorithms
Okay.
that prioritize content based on recency, popularity,
Yeah.
and even a user's past interactions.
It's a fascinating mix of technology and psychology.
Yeah.
I also remember the book mentioning pre-generating feeds
Yes.
to further improve performance.
Uh-huh.
So instead of creating the feed on the fly every time a user opens the app,
Right.
you pre-calculate it and have it ready to go.
That's a great way to shave off those precious milliseconds
Right.
and create a smooth, responsive experience.
It's all about minimizing those loading times
Yeah.
that can frustrate users.
Exactly.
Okay, so we've tackled storing and retrieving photos and videos
Sure.
and even creating those personalized feeds.
Uh-huh.
But what about Dropbox?
Okay.
They're all about Syncing and offline access?
That's a whole different ballgame.
Yeah,
With Dropbox, the focus shifts to efficiency and reliability.
right,
Users expect their files to be seamlessly synced across all their devices,
right.
even when they're offline.
And they expect those files to be safe and sound.
Yes.
Data loss is a nightmare scenario.
Absolutely. The book talks about chunking files
Oh.
for efficient transfer.
Right.
Instead